Assalamu alaikum students. In today's session, we will cover the following topics: electrons and filling electron levels, mass number and isotopes. After watching this video, you will be able to understand that electrons are bundles of energy. They revolve around the nucleus in special paths called shells. Each shell has different. You will also learn how to draw atomic structure of different atoms and how to show distribution of electrons in shells, mass number and isotopes of different elements. You will learn to calculate the number of neutrons in an atom. As you have read in previous topic that an atom is composed of three main particles: electrons, protons and neutrons. First of all, we'll discuss what are electrons and where do they revolve. Electrons are actually negatively charged particles of an atom, and they are not like solid balls. They are bundles of energy. They move around the nucleus in special energy levels called shells. Why do we call them energy levels? Because each shell, each path has different energy than the other. That is why each shell can also be called as energy level. As I have told you that each shell has different energy, so first of all we'll discuss the shell with lowest energy. The shell that is right next to the nucleus has lowest energy and it is named as K shell. You could see in this diagram of beryllium element, in the center the nucleus is shown, in which proton and neutrons are shown. Right next to the nucleus there is first shell. This shell has 2 electrons. This is K shell. It is nearest to the nucleus and it has lowest energy. Now take example of these two elements, beryllium and boron. As you have seen in the nucleus, there are 4 protons in beryllium, which means it has 4 electrons, as number of protons and electrons are equal in an atom, which makes the atom neutral. If it has 4 electrons, then 2 electrons will be accommodated in first shell named K shell, and rest 2 will go in the next shell, which is L shell. Let's take another example of boron. Boron has 5 electrons and 5 protons. Protons are inside the nucleus, while out of 5 electrons, 2 electrons will be accommodated in K shell, which is lowest energy shell, and rest 3 will go in the next L shell. As the distance between the nucleus and the shell increases, the energy of the shell increases. Why is this so? Because as the shells are away from the nucleus, the hold of nucleus towards those shells decreases. That's why their energy increases. As they have different energies, we name them with different alphabets: K, L, M and so on. Except first shell, which is having lowest energy and near to the nucleus, so it can accommodate only 2 electrons. Rest can have 8 electrons. Why they can have more electrons? Because they have more energy and they can accommodate maximum 8 electrons. Now we will take different examples of different elements having different number of protons and electrons, and we'll see that how electrons are distributed in different shells. First example is of lithium. It has total 3 electrons. Out of those 3, 2 are being accommodated in the first shell named K shell, and 1 is left, which will go in L. Now you could see there are 3 different elements: hydrogen, helium and argon. They all have different number of electrons. Hydrogen has only 1 electron, so it is right next to the nucleus in the first shell. As you could see in the nucleus, there is no neutron in hydrogen atom. Helium has total 2 electrons. The both will be accommodated in first shell, as the capacity of the first shell, that is K shell, is 2. It can maximum accommodate 2 electrons. Here is another example of argon having higher atomic number 18, which means it has 18 electrons. If we distribute these electrons in different shells, then you could see here there are only 2 electrons in the K shell, which is lowest energy shell. Then L shell can accommodate maximum 8 electrons. M shell can have 8 electrons too. Except first shell, rest shells can accommodate maximum 8 electrons, as you could see in the diagrams. Now see, atomic number of magnesium is 12. So magnesium has 12 electrons. Its K shell has 2 electrons. L shell has 8 electrons. 8 and 2, total 10. 2 are left, which will move towards the M shell. Calcium has 20 electrons. 2 will be accommodated in K shell. 8 will be accommodated in L and M shells. So they become 18 now. 2 are left, which will go in N shell. See, sodium has 11 electrons. 2 will be accommodated in K shell. L shell has 8 electrons and N shell has only 1 electron, which is. I hope you have understood how to distribute electrons in different shells, and you have seen many different diagrams of different atomic structures of elements. Now I'll tell you how to draw atomic structure of an atom. While drawing the diagram of atomic structure of an atom, you should keep few points in your mind so that you would be able to draw proper diagram. First of all, you all are supposed to draw a circle to show the nucleus using compass. You would mention number of protons and neutrons inside it. Then draw more circles around the nucleus to show different shells, but the distance between shells should be equal. After drawing the shells, you can draw small circles in the shells to show electrons. This is how you can draw atomic structure. I hope up till now everything is clear to everyone. As you have seen atomic structures of different atoms, now I'll tell you about mass number. You can see in this diagram, protons and neutrons are inside the nucleus. So, the sum of protons and neutrons is called the mass of an atom. It is also called as atomic mass. See in this example, beryllium. It has 4 protons and 5 neutrons in its nucleus. So, its atomic mass or mass number is 9, as mass number is sum of protons and neutrons, and if we'll add 5 neutrons and 4 protons, the answer would be 9, which is its atomic. Okay, if you are given with the atomic mass and atomic number, then you will be able to calculate the number of neutrons in an atom. Here is a table. that is showing different elements and their atomic number and atomic masses. I'll tell you how to calculate the number of neutrons in these elements. As the atomic number of oxygen is 8, its atomic mass is 16. It means it has 8 protons and 8 neutrons, because atomic number represents number of protons while atomic mass represents sum of protons and neutrons. If we know the protons are 8, then out of 16 you will subtract 8 and you will get number of neutrons according to the formula that is given at the top. Number of neutrons equals to atomic mass minus atomic number. Now you can see different examples, like sodium has 11 atomic number, means 11 protons. Its atomic mass is 23. If we'll subtract 11 out of 23, 12 is the answer, that is equal to the number of neutrons in sodium atom. Nitrogen has 14 atomic mass and 7 atomic number. So if we'll subtract 7 out of 14, we'll get 7, that is the number of neutrons. In hydrogen atom, atomic number is 1, means it has 1 proton and its atomic mass is 1. As atomic mass is sum of protons and neutrons, if we subtract 1 out of 1, the answer is 0, which means it has no protons. Now we will discuss isotopes of an element. Different versions of same element are known as isotopes, as elements are made up of same kinds of atom. When atoms of an element have same number of protons, means same atomic number, but different number of neutrons, which makes their atomic mass different, then they are said to be isotopes of an element. In isotopes, the atoms would have same number of protons but different number of neutrons. Their chemical properties would remain same. Why is this so? Because they have equal number of electrons and they will make equal number of bonds with other atoms. But their number of neutrons are different. That is why one atom would be heavier than the other and the other would be lighter than the other. In this way, their physical properties change, but their chemical properties do not change. There are different elements which have isotopes like hydrogen, carbon, uranium. Here we will discuss example of carbon. There are 3 isotopes of carbon: carbon 12, carbon 13 and carbon 14. As you can see, they have same number of protons, 6 in carbon 12, 6 in carbon 13 and 6 in carbon 14. But their number of neutrons vary from each other. Carbon 12 has 6 neutrons, 13 has 7 neutrons and 14 has 8 neutrons. So carbon 12, 13 and 14 represents their mass. They are given the name 12, 13 and 14 because of mass number, as it varies from each other because of different number of neutrons in its nucleus. Now let's discuss the occurrence of these 3 isotopes. Carbon 12 is commonly found and 99% is its occurrence. Carbon 13 1%, while carbon 14 is rare. I hope you have understood well isotopes, atomic structure, distribution of electrons in shells and atomic mass or mass number, and you are able to answer these 2 questions. Number 1, draw atomic structure of potassium to show distribution of electron in shells. While keeping the points to draw atomic structure in your mind, you can draw structure of potassium having atomic number 19. Question number 2. Define isotopes and explain each isotope of carbon element. First of all, you will define isotopes and then you will discuss each isotope of carbon, that is carbon 12, 13 and 14. That's it from my side. Thank you for your listening.